Hello, everyone. Welcome to another session from Digital CRM, another Hangout on Air, which is basically it gives you a glimpse about our program regarding disruptive technologies, which is scheduled for June, the last week of June, 23rd and 24th of June to be precise. Now, as per the format of this Hangout, we are going to be covering in brief the four domains that we cover in detail in our program, which includes artificial intelligence and machine learning, AI and machine learning, and then the Internet of Things, cloud computing, and finally virtual reality and augmented reality. So without let's the format is that we are going to give you a quick glimpse into each of these domains about a very basic overview about what it is and what are some of the possible applications, because the possibilities are many. And then we will move on to some of the questions that we have received, the detailed questions, and some more questions which we could be receiving during the session itself. So having said that, let me start off by quickly telling you a little about artificial intelligence and machine learning. Now, artificial intelligence is essentially the science and engineering discipline of making intelligent computing machines or software. It is closely related to, but not quite the same as, the task of understanding and simulating human intelligence, since machine intelligence can employ methods that are not quite found in biological intelligence. Now, branches of artificial intelligence include logic, inference, pattern recognition, search, common sense knowledge, and also experiential learning. The ultimate goal of AI is general intelligence, a machine that is capable of performing a host of different types of intelligent functions. What we have now are artificial intelligence that can perform well in restricted domains. Now, this includes artificial intelligence applications, could include speech recognition, natural language processing, translation, machine vision, image processing, to name just a few. Now, in a very small way, artificial intelligence and machine learning approximates how a child learns. So, essentially, you learn from your experiences, and you learn from your mistakes, and you learn from actions that happen, and the outcomes of those actions, and whether they are right or not right, or whether they can be improved on. Very briefly. Now, machine learning, some of the, for example, some of you would have seen the news reports about Google's AlphaGo. Now, Go is a very complex game which originated in China. It's said to be much more complex than chess. And the recent results where AlphaGo, which is Google's artificial intelligence engine, basically trained and focused on playing Go with one of the top humans, which is Lee Sedol. And as you might have seen, the results were startling. They played 5 games together, and it defeated Lee Sedol in 4 games out of 5. So machine learning techniques also include neural networks of various kinds, support vector machines, evolutionary and swarm optimizations. Now, that's a very quick overview about a domain which is vast, and about which, of course, we go into a lot more details during our regular program, which goes over 2 days. We cover artificial intelligence and machine learning over 3.5 hours or so for half a day. I will, at this stage, pass this on over to Subhamoy, who is here with me, and he's going to be telling you about the Internet of Things. So on to you, Subhamoy.
Sure, thanks, Raja. So Internet of Things is a pretty popular term these days, but most of the time we are not very sure that what it is about. So if you look at IoT or Internet of Things, it's finally a network of physical objects. I mean, objects can be devices, can be vehicles, can be buildings, or many other items. And essentially, they are embedded with electronics or software and sensors with some network connectivity, so that these are different nodes talking to each other, collecting data and doing a lot of activities without human intervention. So IoT as such is expected to grow to a 1.7 trillion as per IDC report. uh, I mean, you can imagine that today you are carrying one or two mobile phones, but when IoT is coming in its full-fledged manner, you'll have many such sensors all over your house, all over your bodies, possibly. So that market is tremendous. The volume is going to grow like anything. So it's also expected that the number of IoT connected devices would grow to over 30 billion during that 2020 period. And if you look at as an industry, the most of the spending will be happening on the endpoint devices and the infrastructure and connectivity. So for this, even technology is evolving. I mean, the way it works today, the way devices connect and talk to each other needs to change when it goes into IoT domain. So the beginning of IoT was in computers, tablets, and phones, but the next set will be TV sets, cameras, especially surveillance devices. Uh, uh, and IoT has a lot of connectivity with cloud computing. We'll talk about cloud computing as a next step, but you can imagine that millions and billions of nodes talking to each other over a network, and they are having two types of sensors. I mean, if you are into technology, you might know that there will be some data gathering and there will be some actuators which will do some work as well. Uh, So solutions will not be static, and their evolving behavior will need to vary depending on local characteristics, giving rise to software-defined functions at both the edge as within the data center. Also, the numbers will be vast, and their operations cannot require human intervention. That's very key, because here we're talking about automation to a large extent. We can talk more on IoT, possibly in the sessions that is coming up very soon, as Raja mentioned. And we can get into the next topic, which is cloud computing. So cloud uh, is also another keywords that is in vogue these days, but cloud is also connected to IoT. So what it is about? So if you look at cloud, it's another way of planning IT infrastructure. If you look at the way the IT infrastructure used to happen, possibly 5 or 7 years ago, the data centers or the servers used to sit in the premises of the organizations. Then the next wave came when the servers came out of the organization to a data center. So these data centers are managed by third-party vendors who will do the cooling, will do the maintenance and stuff. That way, the dependency on the in-house maintenance went off, and it went into a outsourced manner where you can put the data, you put the servers in certain data centers which are well managed. But there is a catch in that. So if you are going to rent out some servers in a data center, you need to upfront tell them that I need so many racks, I need so many servers, cores, and stuff. And most of the time, people plan it for the worst case behavior. So suppose I have a peak load sometime in December or sometime in October, then my entire year's planning needs to happen in such a way that it can cater to the worst case scenario. So here, cloud comes with a solution that it's kind of on the go mode. So whenever you need whatever you need, you can ask for that. You can start with some basic requirement of the server, and it can grow over time just on a tap of a mouse. So you can actually this whole cloud computing has pulled out the server management stuff into a website. You can manage it over a website. There are many vendors in the industry. Amazon is one of them. Microsoft has offering. Google also has offering. So they have their cost, strengths and otherwise. Now, if you look at it as an industry, there was a recent Gartner worldwide IT spending forecast where it was found that in 2015, the data center spending had gone down by 3.8%, which is fairly indicative of the way things are going to happen in the coming years, that the spending on data center will possibly come down and people will spend more on the cloud, because it also helps in the bimodal IT, which is the way people are doing IT these days, that there will be a standard stream of stuff and there will be innovation. So we'll stop at that. Again, if you want to know more on that, we can get into details when we have the session on cloud. I will leave it to Raja now for taking up the next topic.
Yeah, thanks, Shubhaman. We're now going to be covering the last of the four domains that we mentioned initially. We have already gone over artificial intelligence and machine learning. Then we looked at Internet of Things or IoT. We looked at cloud computing, and now we come to AR and VR, which is augmented reality and virtual reality. Now, let me start by giving you very crisp definitions about what each of these are, because sometimes there's a lot of confusion, there are overlaps, and there's confusion about how exactly they are distinct from each other. Now, augmented reality may be defined as a live, direct, or indirect view of a scenario whose elements are augmented or supplemented, if you like, by computer-generated sensory inputs like sound, graphics, video, or GPS data. Augmented reality is also closer to a more generalized concept, which is known as mediated reality, in which a view of reality is modified, maybe diminished even, by computer technology. And computer technology therefore functions as an enhancer of the contemporary and the live reality. Now, this involves the integration of digital information or images with live video or the user's actual environment in real time. And AR starts with, say, an existing image or a series of images or a camera shot of a real-time environment. And then it starts transposing digital information or additional images or objects onto this. Now, sophisticated AR programs could be used for training and could include machine vision, object recognition, or even gesture recognition technologies. Now, virtual reality or VR, on the other hand, is often referred to as computer simulation. And this is the creation of a scenario or a series of scenarios which are not really linked to reality or superimposed on them, but they depict a planned and controlled and fantasized scenario very realistically, making the viewer kind of suspend disbelief temporarily and accept that as the real environment at that point in time. It primarily acts, of course, through two of the senses, which is sight and sound. The simplest form of virtual reality is a 3D image that can be, say, viewed interactively on a computer screen and manipulated using, say, the keyboard or the mouse, so that the image can be moved on different planes and in different directions and also zoomed in or out. Now, more sophisticated approaches to this could involve wraparound display screens or rooms augmented with wearable computers or haptic devices, that is, devices which give you a kind of a tactile feedback and that let a viewer feel the image on the screen. Now, that's really a very quick definition and an overview of what AR and VR is all about. Let me quickly touch upon some of the applications. This is a very rapidly evolving field, and the applications are growing by the day, and there are newer areas which are being explored. But some of the applications would be, for example, some of the applications you'd have seen already. If you've seen a weather forecaster in a TV news channel, and where he or she is forecasting the weather, and if you see the changing maps, behind the forecaster, which depict which have visual depictions of like weather conditions, whether it's rainy or sunny or cloudy and stuff like that. Now, that's one application of AR. Then navigational heads-up displays, which could be embedded in the windshield of a car, is another. Displaying, say, historical and pertinent or relevant information about a tourist attraction. So let's say when you are near the Leaning Tower of Pisa, you look at the Leaning Tower of Pisa, and maybe you can browse the entire history of the Leaning Tower, and maybe see the GPS data, see maybe various events, images of events which may have major events which may have happened near that location, and so on. Now that is another application. One other application could be, buying clothes. Now, this is an area which has been challenging online because, buying clothes involves also trying out clothes in terms of fit in terms of seeing how you look in them. But AR and VR could go quite a way in solving some of those challenges by letting people virtually try on clothes and see themselves in various clothes and see how the fit is and how they look, in different kinds of clothing. So that's another application. Mobile marketing involving product highlights, relevant information displayed over that product or its location. So when you look at a product, you possibly can see the product specs, can see the product in some key applications, engaged in some key applications and so on. That is another way. And then the development of an imagined environment for a game or an interactive story. Now this is really VR territory, and there's a lot of work going on here. All the realistic video games or the 3D games which are kind of being developed. This is where a lot of work is there. Also, it could help in the simulation of a real environment for training purposes or for educational purposes. I mean, supposing like if you're giving, say, training about how somebody is to drive a car. Now you could have the controls there, and you could simulate an environment where this person is actually kind of going through maybe a crowded street and navigating and controlling the car through controls that he has on screen, or maybe on a keyboard or on a mouse or on a pad, and that could serve as a training where you could when he's making a mistake, you could have messages popping up saying that you're not doing this right, or you're doing this right, and this is what you should do, and so on and so forth. So that's briefly about AR and VR and some of the applications of AR and VR. Now, having gone through all these domains, let me take up a few of the questions that we have been receiving, and I what I do is I'll take the question, and I'll read out the question, and maybe Subhamoy can pick up the answer. Okay. Now, yeah,
so
one. Sorry. Yeah, were you saying? Yeah. Okay. One question would, I think one of the most common questions that we have is people asking, because if we look at our 2-day program, it is typically directed at, and it is typically meant for functional managers, departmental managers of organizations, corporations, and so on. And these need not necessarily be people who are in IT or CTOs or CIOs and so on. When we say functional managers, they could be functional managers in the areas of sales, business development, marketing, customer support, any of these areas, or maybe even manufacturing and HR and areas like that. So one of the most common questions that we face is, and we understand this question very well because the course that we have devised is currently, I think, a fairly unique one, and where we cover all these 4 domains that we briefly talked about, and we talk about the applications of these domains, and we try and get into case studies as well, so that people can relate to their environment and their organization and see how best they could apply it in their context. So coming to the question, though, it says, why is it necessary for functional or departmental managers who may not be handling IT or MIS or who are not CTOs and so on to know about this? And why can this not be left to the IT or the MIS guys? Now, Subhamoy, would you maybe try to address some of those issues which are there raised in that question?
Yeah, sure. So, I mean, the question is right, that why should it be not left to the IT or MIS guys? But if you look at it that way, so the traditional IT or MIS departments may not be the right group to handle these new technologies. So possibly if you have a traditional IT setup, they are good at setting up servers, they are good at maintaining the ERP and stuff. But for this new sort of things where we are talking about AR, VR, data analytics, cloud, possibly we need to set up a new group called data science group, for example. Also, it's very important that the functional guys, functional head, or their teams understand the understand the possibilities through these technologies. That's why they are going to relate this technology with their business needs. So, if they don't understand what it is about, they may not be able to come out with some ambitious deployment. So that will fail the purpose altogether.
All right, thanks, Shubhaman. If I may just quickly, add a couple of thoughts to that. See, I think in any organization, uh, functional and departmental managers know their priorities and know their key objectives and goals best. Now, key objectives and goals of a department or even of an organization cannot be determined by either, say, an analyst or a data scientist or the CIO of that organization. As you all know, the CIO, CTO is typically it's a back office function. So they bring in the technology, the tools, the apps necessary to implement, a particular desired task and churn out results, which then go to the relevant functional managers and the departmental managers and the heads of maybe the CEO and the CEO and so on. So like Subhamay was saying, it is really for the functional manager or the departmental head to envisage how best any or one or more of these technologies could be deployed in his given function or in his given domain, essentially to meet maybe to do the job better, to maybe increase productivity, to increase efficiency, to control costs, to expand markets. No, I'm just saying I'm just saying some of these things because these are some of the most common objectives that functional departmental managers have. Customer support or service obviously would have tasks about in addition to efficiency, productivity, and so on, customer satisfactions and how to enhance customer satisfactions, how to increase the degree and the percentage of positive feedbacks and positivity and so on. So these are objectives which the functional manager defines, and once he's clear on these objectives, he then has to correlate it with one or more of these domains and the tools available. See, the tools available and the apps is going to be decided by maybe the CTO or the CIO or the analyst or the data scientist. But the functional manager needs to spell out saying, hey, this is what I want done. And can I use maybe artificial intelligence or maybe cloud computing and or Internet of Things, etc., to do this job and to meet this objective. So that's what it is all about. Okay, having I'll take up one more question because I think we really are coming to the end of this session, and because I think number of the questions we have already answered during the first part when we talked about each of these areas and gave you an overview. The second question is, for implementing some of these, are they applicable and available to organizations in India? Are the tools available? Is the know-how available? Is the technology available? Are the people available? Now, I'm combining this into kind of one query, but these are really the queries saying, are the resources in terms of tools, apps, people, know-how available? And Shubhama, would you like to answer that maybe in a composite fashion?
Sure. So, I mean, if you look for a short answer, the answer is yes, definitely it's available. Now, what sort of tool we are talking about? Suppose we are talking about cloud. So, cloud, we have multiple platforms that we briefly talked about. It's about the I think guys to decide which platform he is more comfortable. If you look at big data, when you have open source tools available like Hadoop and Spark, there are many AI or ML tools also available. So if you look at the summary that way, or say for example, if you go to the CRM, there are many open source solutions as well as licensed products available. For data analytics, you have SAS or you have ClickView sort of things. So options are there. I mean, it's all only about you need to decide which tool is more fit for your requirement. And it need not be a very costly affair. It can be low cost as well as a free solution. So the primary focus that you need to do is first define the problem statement and then find out which tool set meets your requirement, and then you come out with the solution.
Yeah. Thank you, Shubhamay. I think that, you know, that just gives you an idea. See, the tools are available, and the short answer to that question is yes. All this is available, and all this is applicable. The people are available because today the phase lag between of course, while a lot of this work and a lot of these developments and the tools and apps are typically being developed in North America, in the West, in some of them in Europe and so on. But the phase lag between something becoming applicable and available there and becoming applicable and available here is pretty small these days. So, leave that. I would say to the specialists, to the data scientists, or to the analysts, or to the technology guys, to determine which is the most appropriate app or tool for meeting your desired goal or objective. So, yeah. So I guess that brings us to the end of this session, and we will keep on having these in future, because you'd have, I'm sure you'd have some more issues and some more queries and so on. But meanwhile, do look up our site, where we have a lot more details about the program, what are the key takeaways, what are the objectives, who are the focus groups for this, and keep your queries coming in. So thank you all, and thank you, Subhamoy, for participating in this hangout and for helping clarify some of the domains and some of the queries.
Sure.
All right. Okay. Take care. Have a good day, and bye.